Welcome, this is the 7.1 Ready Set Go Homework Solutions. Here for the ready part, we are asked for a construction. It says to use a compass and circles, and we have to create a certain image here. Okay? Here, what they're asking us to do is, using a compass, draw several circles that have the point A as the center, and those who have the same circle as B as the center. What do you notice about the circle with the center and its intersection? Okay, so the green one is going to have the radius of A, as A is in the center. Okay, and the blue circle is going to have B in its center. Okay, it's the same size. Notice it's the same size there, and it's also supposed to be in its center. Then we should notice that its intersection is right there. Okay, the intersection of the two lines of the intersection of the two circles is where the perpendicular bisector is created, because it creates two equal pieces here on both sides, and it creates a 90 degrees from the line. That's why it's called a perpendicular bisector. Right, just to get you to see some numbers, imagine if the green circle here was 6 and the blue circle here was also 6. The radius is both the same. When you combine them right here, notice that they have the same radius. Its intersection here with the perpendicular bisector creates two equal segments. The left hand side would have the value of 5. The right here would have the value of 5. And you're like, wait, isn't it supposed to be 6, 6? No. Do you see the area here that it's overlapping? That's that 1. Okay, you don't include that overlapping area. That's why the length here is still 5. Okay, because right here, the line here is the perpendicular bisector. Okay, good? Good? Alright, remember, the intersection of the two circles on this segment is a perpendicular bisector. Alright, next, number 2, it says, in the problem above, demonstrate one way of finding the midpoint of a line segment. Explain the other way that you can do that. Again, you could apply the rule of reflection in our transformation. We can reflect the A on top of the B by folding the paper so that the line overlay each other. You can still create the same image. Okay, so construction can occur by transformation as well. Alright, the set part. Here, all of them ask you to do construction. And what I did is I am going to bring it in all these have very easy steps that are already done for you. Okay, so the first one, it's constructing a angle bisector. Okay, here's step 1. You draw an arc such as the angle A here, placing the compass at A at the center and drawing the arc from B to C. Okay, then you place the compass back at the B or C and you construct a intersection outside of that original arc from B to C. Right here, step 2. Then step 3 would just be drawing a ray or a line segment from A to that new intersection. You could call that G if you want. Here you could say that the ray AG bisects angle A, creating two equal angle segments. Angles. The two angles that it makes is CAG and GAB, are the two angles that are made from the angle bisector. Okay? There's not a lot of explanation on why. This is just how it's done. Okay? So this is just memorization. There's no real thought process to this. Alright, next, I think 4 asks you to construct a segment. How to copy using a compass and straight edge to construct a line segment that has the same length as AB. So if this is 5, create another line segment that is also 5. Alright, here you go. So you're going to use a straight edge to draw a line segment no longer than AB and label it C. Alright, because it's a new point. So label it anything. Here they label it C. You want to use your compass to measure the length. So measure AB. Then you copy that exact point pacing going to point C. So place the compass at the new point C. Mark point D on the new line segment. So now CD is the same thing as AB. There's not really anything new about this, okay? There you go. The next one asks you to do here, this is another way for you to get the bisector if you want, or the midpoint, I mean. Draw the line segment AB on a piece of paper. If you fold the paper so that A and B are on top of each other here, then once you fold it back, you have, and that midpoint, that point that you are folding the paper, you could call that M for midpoint. You notice that AM is equal to MB, such that they are both 1/2 of the AB line segment. Next one. They asked us to copy an angle. Here you go. Alright, draw an angle such as angle A, as shown. Then draw a segment labeling point D right here on the segment. Then draw an arc with the center A right here. Using the same radius, draw an arc with center D. So they made an arc here from B to C. They copied that same arc but using the point D here. Likewise, step 3, label B, C, and E. Draw an arc with a radius BC and center E. Label the intersection of F. Next, draw the ray from D to F. Once you draw the ray, you have two angles that are the same. Okay? Again, the constructions, there's not a lot of thinking involved. They're just memorization of steps. Okay? That's it. Because there's no other way of doing it. Alright. Number 6. Construct a rhombus on the segment A and B. That is given below. And that has the point A on its vertex. Make sure to check that your final figure is also a rhombus. Okay? Alright. So this is A and this is B. Okay? Alright. So, first of all, I'm going to just grab this. Because I drew a circle. Okay? Good. This is the radius of this circle. I could even make this a different color if you like. Okay? No, that's a bad color. Purple. Yeah. Alright? The black line is the radius of the purple circle. Good? We can get something else from this. Alright? Watch. Okay. If I make that also the radius of the same circle, same size, right? That's also the radius. I could also grab another radius. Okay? Because remember, the radius is the same. So this line segment on this circle, right? They're both the radiuses of this circle. So they're the same length. Good? I'm going to extend this a little bit further right here so that it is the center. Right? Trying to get the center of the circle right there. Perfect. Okay? Then I can just draw another line segment. Right? Oops. Alright, so boom, there you go. Alright. From here, I could also get another one. So, it should look like this. Okay? That would be your first circle that's creating these two radiuses. Alright. Then that would be that circle for that radius. That circle for that radius. And that circle for that radius. So, hold on, let's see. There's supposed to be 4. 1, 2, 3, 4. Here, let me color code it for you. So that was going to be the original purple. Whoop. That's that's gonna be the original purple. This one I could make that orange. That's for this orange line. Okay, that's this one could be green, and that is gonna be that radius. Oh, that's a little bit off. Yep. And this one can be red and gives me this radius. Okay. Alright. Notice how every single circle gives me the radius. Right? So I construct a rhombus by using the radius of 4 circles. Makes 4. And each circle is the same value. It has the same radius. Why? Because in a rhombus, all the sides are the same. That is how you construct a rhombus. Good? Alright. Red circle, red radius. Purple circle, purple radius. Right? Green circle, green radius. Orange circle, orange radius. Boom. Next, construct a square. Alright. I already have the segment out here to make our lives easier. Okay? Because 4 sides, 4 circles. Okay? Alright. Let's just grab the first one. Let's just make this black. Okay? So it makes our life easier. Good. So this is the radius of the black line. Okay? From here, I can also see that there is another radius. Boom. Right? Okay. It's not the best. Alright, so, okay, this is the circle, right? We have our original line. This is the circle. From there, we got this radius. Again, how? Because, again, each circle, they have the same radius anyway. So, I just drew a line from the center up, gets me that part. Good? So, this would be the 2 radiuses coming out of this circle. I'm going to call this the black one. Okay, next, same circle, but I'm going to make it a radius, this one. Okay, this one is probably going to be red. Oops, sorry. This one's going to be red. This one is also going to have that same radius, but this one's going to be red. Okay. From here, this one also has a radius going up from the center. As well. Good? Okay, next. I'm going to create another circle here. And I'm going to call this blue. This one is also going to have a radius going down. That is going to be blue. Likewise, it's going to have a radius from its center to the left. That's also going to be blue. Okay, good. Draw another circle here. I'll make this one green. This green circle has a green radius from its center to the circle, right? Center to the touching of the circle right there. Likewise, it's going to also have a radius going down from its center, which is right here. That's also going to be green. There you go. So, here is my construction of my square. Okay? 4 circles. Each circle, I use its radius. I drew each circles, all the radius are the same. Okay? I have a radius that is going from its center to the right hand side and up, or left hand side going down. In this case, the black circle here, I drew 2 radiuses, one from the center going right and I think one going up. Likewise, the red one, it copied that same radius from the black circle, right? but it's going to be the red circle center to left as well as center up. Blue circle center down, which is a copy of that red, as well as center to the left. The blue circle center to the left is the green circle center to the right, which is green, then center down, which was the original black's center up. Okay? 4 radiuses. Alright? 4 circles. That's how you construct your circle, your square from using circles, okay? Alright. Okay. Good. Next. Given the equilateral triangle, find the center of rotation of the circle using a compass center strategy. Alright, very straightforward. Do you see this angle here? Here, let me just color code this. Ooh, green looks nice. Green. Alright, do you see this triangle? This angle? Green. Okay, draw a ray such that you have creates once you construct that ray, it creates a bisector, creating equal angles and an equal distance here. Alright. There's another name for this. Okay, I think it's called the orthocenter or the centroid. One of them. Or circumcenter. It's one of them. Alright. Then I construct this again, but on the other side. So the center is going to be right here. Draw the angle there. And oops, creating this piece, good, and this piece. Alright, so this ray is creating these two equal segment bisectors, creating this ray is creating a midpoint such that creates two equal segments. Going from this vertex, creating a ray, going down, right? Creates, boom, one and two. Good. And the center here would be that. Alright. Let me see if it's actually called a centroid. Hold on. Is it called a centroid? I'm just curious now. No, or is it the orthocenter? Yeah, no, it is a centroid. Yeah. Here, I could grab the picture for you. Hopefully it copies. Yep, there it is. That is how in front of text. So, this is how the centroid would look like. Okay. The centroid is created from the vertex to the side, such that you create segment, right? Two equal segments, two equal segments, two equal segments. They're not really perpendicular bisectors because do you see how this is not a 90 degrees? So they're not perpendicular bisectors. But it creates, you know, two equal segments and it coming for the vertex, okay? And this is called a centroid. If you want to, oops, sorry. This is if you want to know how it's spelled. It's called the centroid. Alright, good. There you go. Alright, let's look at 9. 9's a review of solving systems of equations. The first one, I'm going to solve it by substitution because x is already solved for. You have x equals to 1 plus y. You're going to solve, so it's already solved for. So I'm going to use substitution. Okay? Alright, here you go. I worked through all the steps for you. Step 1, right? I'm going to look for the opposites. Or, sorry, step 1, I'm going to use the second equation. But, okay, so that is my second equation. So, the equation that nothing is solved for. Then I'm going to substitute the first equation into the second. I wrote that wrong. Okay. Notice how this was x, but now it becomes 11 plus y because that is that substitution. Okay, distribute 2 times 11, 2 times y, simplify, gets you 22 plus 2y plus y equals to 19. Combine the like terms. How do I get the 3y? That comes from 2y plus y. Subtract 22 to both sides, get you negative 3 on the right hand side. Then divide by 3 because, again, we need the coefficient of 1 in front of the variable. Get you y equals to negative 1. We're not done. Solutions to systems of equations must be in order pair. So, here's my first equation. Again, you can use the first or second equation, either or. I'm going to use the first equation because x is already solved for. Right? Y becomes y equals to 1 because that's what we just solved for. 11 plus negative 1 is x equals to 10. My solution in solution format, in order pair format, is 10, comma, negative 1. That is my solution to this system. 10. Here, I'm going to solve this by elimination because I see a negative 4 here and I see an x here. Alright, I could make opposites here. Okay, I cannot do this by substitution. I can, right? If I add 3y to both sides like this, do you see it's negative 3y? I can do this if I want. And makes my life easier. Okay. Alright, you see how I could do it by substitution. But I'm going to leave it like this. Do it by elimination. Okay. I can't graph it because it's 9y equals mx plus b. I can. I just have to do some algebra. Alright, step 1, I'm going to look for some opposites, right? It was negative 4, and there's actually a 1 in here, but I don't know if you notice. Right? If you never see that coefficient in front of the variable, it's always 1. Okay? So, I see negative 4, and I see 1 here. So, I'm going to multiply by 4 to the second equation. That process, I get 4x minus negative 12 equals to negative 24. How do I get that? 4 times x is 4x. 4 times negative 3y is negative 12y. 4 times negative 6 is negative 24. Add the two equations. Negative 4x plus 4x disappears, right? Eliminates. 9 plus negative 12y is negative 3y. It's a negative 3 because it's a negative 12. 9 plus negative 24, it's negative 15. That's my add the two equations. Step 3, you want to solve for the variable now. In this case, you divide by negative 3 to both sides. Negative over negative gets you a positive. So y equals to 5. Right? Step 4, substitute the solved variable back into one of the original equations. In this case, I use the second equation. Can you use the first equation? Yes, you can. Same answer. Right? So the y right here was y equals to 5. So I make that substitution. Y equals to 5. Right? This was y. This was y, now it becomes 5. Negative 3 times 5 is negative 15. Add 15 to both sides because you're trying to get the variable known as solve for it. You get x equals to 9. My solution is y equals to 5 and x equals to 9. In order pair format, it is 9, comma 5. Okay? I did 9 and 10, showed you all those steps. For the other ones, I'm just going to give you a solution. If you need more detail on how to do it, review one of my old videos on how I showed it to you in more detail, or look at 9 and 10, right? I didn't do the graphing method for this. Okay, 11, the solution here was 8 comma 3 over 2, 12 0 comma 1, 13 3 comma 1, and 14 11 comma 37. If you are one of my students and are watching this and just have write down the answer, you are going to get marked wrong. You have to show me the work. Okay, I know it's very tedious, you just have to practice. Okay, graphing 12, right? This is in y equals mx plus b. You have to graph it. This one, straight elimination. Ooh, you would have to multiply by a negative down here. To fix this one, you have to multiply by negative. Okay? It should look like this, right? Negative, then that becomes a positive, then this becomes a negative. Then you could do elimination. This one, so this is by elimination. This is just my preferred method, okay? You could do whatever you want as long as you still get the right answer. This is by elimination. This is going to be by graphing because it's in y equals mx plus b. This is probably going to be by substitution because, oh, I spelled that wrong. Substitution because y is solved for. This one is probably going to by elimination because you see how you can multiply this by 2? So this becomes 8, this becomes 2, and this becomes 14. Right, look, -2 and +2. Okay, there you go. Show all work if you want credit. There you go. Those are all your homework solution for 7.1.